Hello students, in our previous video, we learnt about area of circle. In our today's video, we will learn about area of sector of circle. You have already come across the terms sector and segment of a circle. Recall that a circle is a geometrical shape which is made up of an infinite number of points in a plane that are located at a fixed distance from a point called as the center of the circle. The fixed distance from any of these points to the center is known as the radius of the circle, and the portion of a curve lying on the circumference of a circle is called arc. You already know that the portion or part of the circular region enclosed by two radii and the corresponding arc is called a sector of the circle. There are two types of sector, minor and major sectors. A minor sector is a sector that is less than a semicircle, whereas a major sector is a sector greater than a semicircle. Thus, in figure, shaded region OAPB is the minor sector of the circle with center O. Triangle AOB is called the angle of the sector. The unshaded region OAQB is major sector of the circle. Also recall that full circle makes 360-degree angle, and subtracting angle of minor sector, that is angle AOB, we will get angle of major sector. Therefore, angle of major sector is 360 minus angle AOB. Students, note that semicircle and quadrant, that is 1/4 of the circle, are also special types of sectors of a circle, such that their angles at center are 180-degree and 90-degree respectively. One of the most common real-life examples of area of a sector is a slice of pizza. The shape of slice of a circular pizza is like a sector. A pizza of medium size, say 20 cm radius, is sectioned into 8 equal slices. Each slice will be a sector. If you eat away 4 such slices, can you tell me what portion of whole pizza you ate? For that, you will have to calculate area of one slice and then multiply by 4. So let's learn how to calculate area of sector. The area of a sector of circle can be calculated to find the total space enclosed by said part. The area of the sector can be calculated using formula theta upon 360 into pi r square, where theta is the angle subtended at the center in degrees and r is the radius of the circle. Now let us derive this formula. Let's apply the unitary method to derive the formula of the area of a sector of circle. We know that the angle of complete circle is 360-degree and the area of whole circle is given by pi r square, or we can say that if angle is 360-degree, then the area of the region will be pi r square. Now, if the angle of sector at the center of the circle is 1 degree, then the area of that sector will be area of sector with angle 1 degree is equal to pi r square upon 360 into theta, which is equal to pi r square upon 360, as theta is equal to 1. So, if the angle at the center is theta, the area of the sector is area of sector of the circle with angle theta is equal to pi r square upon 360 into theta, or theta upon 360 degree into pi r square, where theta is the angle subtended at the center given in degree and r is the radius of the circle. Now students, let us see how to find the length of arc that makes sector. Recall that arc is a curve lying on the circumference of a circle. That is, it is a part of a whole big circle's boundary. The length of an arc is equal to theta upon 360 into 2 pi r, where theta is equal to angle of the sector and 2 pi r is equal to circumference of the circle. Now let us derive it. The method is same as that of finding area of sector. Just compare the proportion of the length of full circular arc, that is circumference, and portion of sector. We know that the angle of complete circle is 360 degree. Thus, we can say if angle is 360 degree, then length of an arc will be length of whole circle, that is circumference of circle. But angle is say 1 degree. Then length will be given by 2 pi r upon 360. Now, if the angle of a sector at the center of the circle is theta, then the length of arc of that sector will be length of a sector of the circle with angle theta is equal to theta into 2 pi r upon 360, which is equal to theta upon 360 into 2 pi r. There are instances where instead of angle of sector, you might be given the length of arc or area of the sector. In such cases also, you can use same formula. Let's solve an example. A piece of 22 cm long wire is bent into the form of an arc of a circle, subtending an angle of 60 degree at its center. Find the radius of the circle. Let's take radius of arc be r centimeter. We have length of wire L is equal to 22 cm and angle theta is equal to 60 degree at the center. We know that length of arc, that is wire, can be found as L is equal to theta upon 360 into 2 pi r. On substituting the value, we get 22 is equal to 60 upon 360 into 2 into 22 upon 7 into r. On further solving, we get 22 is equal to 22 upon 21 into r. On solving this, we get value of r is equal to 21 cm. Note students, we have two formulas. Area of sector, which is equal to theta upon 360 into pi r square, and length of arc of a sector, which is equal to theta upon 360 into 2 pi r. Observe that for both formulas, theta upon 360 is common. But to find area, multiply it by area formula, and to find length of arc of a sector, multiply it with circumference formula.